Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the refraction by a spherical refracting surface. So let us do. So before that we need to understand refraction through spherical refracting surface. So we will talk about convex and concave. How many parts are there? So there are maybe two parts. There may be a convex shape as well as concave shapes. So let us draw a convex part first of all. If we talk about this surface, so this surface, it appears to be bulged out. So this type of surface are considered as convex surface, right? This type of things are considered as a convex surface. So let us draw this. So this will be center of curvature. This will be a pole. How I am considering a center of curvature. So if you want to know about this, so let us consider this as a sphere. Sphere, which is a curve is also a part of a sphere. So center of this sphere is considered as the center of curvature. Now let us consider there is a refractive index of this as a mu2. So this type of a surface is known as a convex surface, and there is a refractive index outside, it is known as mu1, right? And if you want to find the radius of curvature, so what you will do, so you will do as a r like this. Now let us go for next one. So that is, let us consider this this surface. So this is the concave part. So that's why this type of things, this type of surface is known as is concave surface. So this whole part is a concave surface. It has a refractive index of mu2. Now if you talk about this, so this whole part is considered as a convex part, right? So this is a convex part. So if you want to find a radius of curvature, so let us consider this. So this and if you this sphere, so this curve is the part of the sphere, and this is a center of curvature, this is a pole, and this is your mu1, this is your mu2, right? If you talk about this, we will talk in this derivation we will go for this, that theta is very small, theta is very small. So sin theta can be approximately taken as 10 theta. So we will do some of the derivation. We will find relation between refractive index and the radius of curvature. So this, if you talk about this, so radius of curvature for this will be negative. R is negative, and for this R is, sorry, it if light is going from this direction, so R will be negative, yeah. And if light is going from this direction, so R will be negative. So we will do all this thing later. Just start the derivation part. Now see, we will talk about the we will talk about the real image. Okay, real image, here we will consider as a real image. So let us consider this is an object, right? This is an object. Okay, now its light is falling on this. So this is the convex part, right? This is a convex part, and it has a refractive index of mu2, and it has a refractive index of mu1, right? So this is a convex part. Now anywhere, if you want to find a center of curvature, so you have to just anywhere, if you want to find a normal, so let us consider this point. At this point you want to find a line which is normal to this. So if you want to find like this, so this is the normal, right? So what will happen? Now think about this. This is the angle of incidence. This is an angle of incidence I. So what will happen? This light should go like in this direction, but what will happen? It will bend toward the normal. So this is your normal line. So what will happen? What will happen? It will bend. If due to high refractive index, this will bend toward the normal. Now let us suppose you can also think that the refractive index is very less, so it may not bend till this, but for sake of now, I am thinking that light is bending in such a way that it is intersecting at this point. Right, it is intersecting in this point. If it refractive index is not sufficient to bend it, so what will happen? It will just move like this. So it will retrace the image backside. That is, it will create a virtual image. But we are talking here that our image formation is real image, right? So this is I. Okay. Now let us nomenclature is. So this is R. This is a radius of curvature. This is image. This is an object distance, right? Okay. This is O. This point, can be considered as a M. Now take a perpendicular line to this. So earlier it was a pole. So this is considered as N, right? And this is center of curvature. Now angle made by the object with the incident ray is considered as alpha. Angle made by image can be considered as beta, and the angle made by this can be considered as gamma, and this is known as R. This is why R, because this is incident angle, so this will be the refracted angle, that is angle between the reflected ray and the normal, right? So this is mu1, this side there is a mu1, and this side there is a mu2, right? So these are the two uh, medium. Now as per the Snell's law, so we will go for as per the Snell's law. As per this Snell's law, as per the Snell's law, mu1 sin I is equal to mu2 sin R. We can do this, right? Now since we have considered that theta is very small, so mu1 I will be equal to mu2 into R. We can write like this. Okay? Got it? Now how we can write as angle of incidence I? So let us consider this is an I. So I will be equal to alpha plus R. Why alpha plus R? Let us think alpha plus R is equal to I, or alpha plus not R, alpha plus gamma. See here. Let us consider this is a triangle. So this is the exterior angle. So this can be equal to the sum of these two interior angles. So I can be considered as alpha plus gamma. So this will be the equation. Also, when we talk about this one R and beta, so can we take that the gamma is equal to R plus beta? See here, R plus beta is equal to, in this triangle, when you observe this triangle, so when you observe this triangle, so we can write here R plus beta is equal to gamma. Of from here R can be written as gamma minus beta, right? Gamma minus beta. So we have this equation, we have this equation, we have this equation. Now put the value of I in this equation. So what we will get? So if you put each and everything, let us we can put here put the value. So what we will get? See here, mu1 into alpha mu1 into mu1 into alpha plus gamma is equal to mu2 gamma minus beta, right? Now here we can say that, can we write this alpha as tan alpha because angle is very small, plus tan gamma is equal to mu2 tan gamma minus tan beta. So we can write like this. Okay, now if you observe the all the nomenclature part, so tan theta, so when see one more thing we need to consider, that p and n, p and n both are very near, both are very near. So we can even consider this as a MP as a MN, right? MP as a MN. So tan alpha. When we talk about the tan alpha, so you just consider this angle, right? So this angle. When we talk about this triangle, so MON. So when we talk about MON triangle, so what we can say that here, what we can say that mu1 into tan alpha means perpendicular by base, that is equal to MN by O OP, right? Why OP? Because OP or ON both we are considering as the same. Now we can also write in this case MNC, in triangle MNC, tan gamma is equal to perpendicular by base, that is equal to MN by PC, and this is equal to mu2 tan gamma is equal to again MN by PC, and minus tan beta. Tan beta, if this angle we are talking about, so this will be mn by pb, mn by ni, or we can say that mn by pi also. So mn by pi, why we can consider ni also, pi also, but because both are very nearby, so this can be written as by mn by ni. Okay, so I hope you have understood this. Now this can be considered as mu1 into mn, since we have seen that mn will get cancelled for each term, because everywhere you are getting common mn, so we can cancel it. So finally we are getting 1 by op 1 by op 1 by op plus 1 by pc plus 1 by pc is equal to mu2 into 1 by pc minus 1 by pi. Now just think the values, mu1 into 1 by op. OP means u, object. So 1 by u will be negative, you know that. U will be negative, minus u, plus 1 by PC. PC means R, so R will be positive. So I have taken as positive. This is equal to mu2. 1 by PC means 1 by R minus 1 by Pi. Pi means Pi. So when we talk about Pi, Pi means V. This is V. 1 by V, right? So this we will rearrange this equation. So finally we are getting mu1 by minus mu1 by u plus mu1 by r is equal to mu2 by r minus mu2 by v. Okay, so we again rearrange this equation. So if we rearrange this equation, so finally we are getting as mu1 by u plus mu2 by v is equal to mu2 minus mu1 by mu2 minus mu1 by r, right? Okay, mu2 minus mu1 by r. So finally we have understood that mu1 by u plus mu2 by v is equal to mu2 minus mu1 by r. This is the derivation. Okay, minus, this will be minus, right? Now one more thing we can see, one more we can get the equation. So what we have done in earlier case, object was in a rarer medium, object is in rarer medium. Now if you want to derive similar expression for when object is at a denser medium, so let us consider an object is at a denser medium. Object is at denser medium. Denser medium. So what will be the medium? Let us consider an object is denser medium. So what you will observe, let us consider this is our spherical refracting surface. An object is here. So it is going like this, understood? So when you will derive all the things, so you will get an expression, and this expression, it just you have to replace mu1 with mu2. So when an object is at a denser medium, so this will become mu2 by u plus mu1 by v is equal to mu1 minus mu2 divided by r. So I hope you have understood this. I hope you have understood this. So thank you for attending our video, watching our video. Thank you. So we will again talk this.